Good afternoon. Welcome to Education World. And today our topic is the organic chemistry. Okay. So before that, we learn what is organic chemistry. So this is a part of a chemistry. So basically, which deals with the hydrocarbon. Hydrocarbon means hydrocarbon and its derivatives. Okay, so in this organic chemistry, so mostly we learn about the hydrocarbon and its derivative or their derivatives. So what is hydrocarbon? From the name itself we can understand. So basically the compounds that are made of only the carbon and hydrogen. Okay, and so the compound mostly it will compose with the carbon and hydrogen, that is the hydrocarbon. And its derivative means whatever the compound will derive from this hydrocarbon, so that will be the its derivative. Okay, so we'll take example later, but this is to define, simply to define. So organic chemistry is a branch of chemistry which deals with the hydrocarbon and their derivative. Okay, so before going to the topic, we'll go through a brief, history of the organic chemistry. So even though we are talking about, we are using the organic compound since long back, like we are using the vinegar, we are using the ghee or the butter. Okay, so those are the organic compounds and we are very much familiar with all these things. But still, according to the scientific background, so the first organic compound that we synthesize in the laboratory, so basically that is urea. And this is we got from the ammonium cyanide. So basically if you hit it, so basically that will give you the urea. Okay. Okay, so this is urea, and you frequently do know, you know that this is we use frequently use as a fertilizer, and this is ammonium cyanide. Okay, so who discovered this? This is the scientist Olhar. Okay, Olhar is the person. So in the first organic compound that is synthesized in the laboratory, so that is urea. Okay, so this is the first compound, and the second compound, it was synthesized by Kolbe, or sometimes people pronounce it as a Kobe. Okay, so that was synthesized was the acetic acid. Okay, and the third compound, so that was synthesized by Berthelot, it was a methane. Okay, so these are the three compounds, where the early three compounds that was synthesized in the laboratory. So first, urea, and then the acetic acid, and third is the methane. But even though this, we are very much familiar with the acetic acid, so that is not nothing but a vinegar. So we are using since long back in our human history. But when we are talking about the science, so basically this is the urea is the first organic compound that was synthesized in the laboratory. Okay, so since we'll see the already in the first topic, we learn about the organic compound. So basically kya hai organic compound? So it is the center of this compound is the carbon. So basically carbon oriented this whatever the compounds or the whatever the compounds will study, so that will be your carbon based compound. So that is why we need a brief introduction about the carbon. So basically we know the carbon, it has a the proton is 6, or the atomic number is 6, and the atomic weight, this is the 12, and this is the most abundant isotope of the carbon. Okay, so if you think about the electronic configuration, the electronic configuration is 1s2, 2s2, and then 2p2. Okay, so this is the two. So basically this is how electronic configuration. And if we talk about in terms of the the shell. So basically this is the K is the first one is orbit, and this is the now L, that is the outermost orbit. So again, when we talk about this, in the outermost shell or outermost cells, we are having 4 electrons. So this is, that is basically the valency of the carbon. Again, we can understand this. So in terms of basically in the ground state carbon, in the ground state in the ground state, so carbon has an electronic configuration. So basically we are having the outermost electronic configuration. So this is, if we write like this, so this is a 2s and no 2p. So that is what 2p. This is how the electronic configuration in the ground state. Okay, so this is the ground state. And in the excited sorry excited state so basically we are having four unpaired electron. So basically 2s electron is promoted to 2p orbital, and then we are having four unpaired electron, so it can form a four covalent bond with the another another four elements. Okay, so that is why we'll see the it has a covalency, or it can form a four covalent bond with the other elements at the same time. So basically we'll see there are very interesting property that make us the carbon is more interesting, as well as it how it can create the lot of compounds. So basically we can think so far the carbon compounds that is known to us more than 5 million. So 5 million. Okay, so if we in terms of like a lakh, so it will be like a 50 lakhs. Okay, so why we are having so many compounds based on the carbon or the organic compounds? Why we are having so many organic compounds? So basically that because of some unique properties of the carbon. So that is why the first unique property is the tetravalency of carbon. So that is we have just explained. So it has a four unpaired electron in the excited state, so it can form four covalent bond with the other element. So this is a like a four, it can form like this, so four covalent bond. So that is called the tetravalency, means it can combine with the four no other element. So not if it is like this for methane, if you have a CCl4. Okay, again we can have CH2Cl2. So basically these are the four different, or the four other element can combine with the carbon atom. So that is why it says like the tetravalency. So it can adapt four other element in its around the carbon. Another is the catenation property. So this catenation property, it means like a self-linking catenation. So the more than 100 carbons, so they can combine together, so something like that, so whether it is a double bond, single bond, triple bond. So this is the property of the carbon. So this is the most interesting property because of the catenation property. So we can have a lot of compound. Okay, that is why we are having lot of carbon compounds. So this is the one of the major advantage of the carbon. So it can form the bond with the same, or this with the same carbon atom. So basically this is called the catenation. It means self linking. Okay, and the next is the tendency to form the multiple bond. So इसका मतलब क्या है? तो we are so far we are talking about the single bond. So whether it is a CH, sorry, H, this is H, these are the single bond. And what is the multiple bond means? So bond means, so the whatever, when it is a single bond, so we call this is a sigma bond. But when there is a multiple bond, so basically this will be like this is like a carbon carbon double bond, or the carbon carbon triple bond. Okay, so this is then when we have having more than one bond, so then one bond is called sigma bond, and the other bond we call the pi bond. So when we are having triple bond. So in the triple bond, so we are having one sigma bond, and the 2 pi bond. Okay, so these 2 pi bond. Okay, so in this case we have to remember when there is more than one bond for any element. So when there is a two elements, any kind of two elements, so when there is a more than one bond, so basically the first bond will be the sigma bond, and the rest other bond will be the pi bond. Okay, so if there is a three bond, so basically हमारे पास क्या होगा, एक ही सिग्मा बॉन्ड होगा, और ज्यादा जितना सारे बॉन्ड्स है वो पाई बॉन्ड आएगा. Okay, so this is the property of the unique property, or that is why it can form the single bond, since it can form single bond and triple bond, double bond. So that is why it has it has some unique property, and it can create many compounds. Okay, and the formation, whatever the bonds we are getting, so the covalent bond, CH bond or Cl bond or Cl bond, or the carbon oxygen bond, so they are strong bond, so that is why it is quite stable. Okay, so because of that, so again we are having the compounds that exist, or because of strong bond, we could see the stable compounds of the carbon. Okay, so another properties is isomerism, we'll discuss later. This is very important property. So isomerism, it says so like it will have a the same molecular formula. Okay, same molecular formula, but different 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 structural arrangement. Okay, so this is called the isomerism. So basically we will have the same molecular formula, but their arrangement, structural arrangement are different. So that will create no different molecule, and their properties will be different. So that will we'll learn in the isomerism chapter, and that is very interesting. So that is why, like, even though we are having same molecular formula, we can get the many variety of compound. Okay, so now the types of compound, the type of compound, it is important. In the higher classes we will see the some other how we can categorize the organic compound in a different manner, but here we can simply learn the types of organic compound. We could divide it into two types based on uh, double and triple bond. We could say the saturated saturated carbon, or saturated compound, saturated organic compound, and unsaturated group of atom, generally group of atoms. So basically that decide the physical So sorry for the interruption. So functional group, the functional group is a group of atoms that present in a hydrocarbon, or in the organic compound. So basically that decide the physical and the chemical properties of the compound. Okay, so this this functional group can be classified into different categories. So here we are having limited scope. So with the limited scope, so basically the functional groups are like the alcohol group, alcohol. So that is the alcohol compound, when we will have the hydrocarbon, it contain OH functional group. OH functional group, that is called the alcohol. And this is, we'll learn again in the nomenclature. So this is represent as all. And then the alcohol, and we are having the aldehyde aldehyde. So this is a functional group. This group of atom is like a, this is the group of atom. So when in this group, so we are having one carbon oxygen double bond. So basically, and another is carbon hydrogen single bond. So basically, this is the functional group, and this group, if it is present in the compound, so we call the aldehyde. And the at the end, so basically in the UPAC nomenclature, the suffix will be al. Okay, so this is called the L. Okay, again, if we are having the acid group or the carboxylic acid group, so this is mostly called the carboxylic acid group. So this is represent like this. This is OH. This is called the oic acid. Oic acid. Okay, in the UPAC compensation. So these are the functional group, and another is like a, if we take, so like a, this is a ether. Okay, so if we have the O, it contains with the, this is this side the hydrocarbon. This is another 2 units of hydrocarbon. So this is hydrocarbon, and this is also hydrocarbon. So basically, this is called the ether. Okay, so these are the the functional groups, and we'll mostly discuss about all these things. And again, this is when the acid will have a derivative. So basically, this we can replace this OH group with many things. So then, whatever the compounds will get from the acid, so that is called acid derivative. Similarly, the OH group, whatever the compound will get, the substitution of the H here, so basically that is the alcohol derivative, something like that. So basically this here we can understand the derivative. Derivative means what are the new compounds will get from this, the acidic functional group, that will call the derivative. So these are the types of organic compounds. So basically here we can say the based on the double bond and triple bond, we are having saturated uh, sorry saturated hydrocarbon or saturated organic compound. Then we are having unsaturated compound, or unsaturated organic compound. Then based on the functional group, we are having alcohol, aldehyde, acid, ether, and there are so many. So maybe we'll discuss later. Okay, so these are the preliminary example of the acid, alcohol, and the ether. These are the things. So now we'll talk about the isomerism. Okay, so the isomerism, this is very important. Because of the isomerism, so we can have many compounds. So basically this we can understand like this. So so if we have a compound like this, for example, we can understand C2H5OH. Okay, so this is from this is if it is a general, the molecular formula from this, what we can get. So this is a OH group. So this is would be, if we do the expand, so something like this. So basically this is the OH is here. So basically this is a alcohol, just now we learn. But this molecule, this molecular general molecular formula, that can be written something like this. So basically this will be the new compound. So basically all we are having C2, basically C2H5OH, or basically if we have C2 H6O. So that is the molecular formula, general molecular formula. From that we can get two kinds of compound. Okay, so this is called the isomerism. Again, we learn about the various types of isomerism. So isomerism, it can be two types. We can divide the isomerism into two parts. So basically one is the structural structural isomerism, and the stereo isomerism. Okay, and this is a structural isomerism. Okay, so the stereoisomerism, this is not in our syllabus. So only we are having the structural isomerism. So structural isomerism, it is again can be further classified into various categories. So we are having the chain isomerism, isomerism, then positional isomerism, and the functional functional isomerism. Then again, it will be another metamerism, and the tautomerism. Okay, so the structural isomer, it could be classified into five different part, but no, these are not in our syllabus. So basically, we'll discuss about the chain isomerism, positional isomerism, functional isomerism, and again the stereoisomerism can be divided into two categories. So that is just for your information. So one is optical isomerism and the geometrical 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 isomerism. Okay, so these are the important thing, but in our topic, so basically we'll just limit it with this chain isomerism, positional isomerism, and functional isomerism. We will understand how we can get different kind of compounds from this chain isomerism. So chain isomerism, so इसमें क्या होता है chain isomerism में actually if we have a compound something like this CH3 CH2 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 uh, CH3. So this is a compound, and the simple name is, if you say, we'll discuss about the name of this compound is the butane. Okay, so butane. Okay, so this is more specific, this is we can call the n butane. N butane means, तो इसमें क्या है, normal butane, or this is long chain butane, just normal butane. Okay, but this structure if you have, this is a general formula. इसका general formula क्या है, तो C4H for 12. Okay, so this is the general formula. This is the general formula. Then, sorry, 10. So this is the general formula, and from this we can have no n-butane. We can have also the CH3, CH3, and CH3. So this is like we can say the isobutane, or the 2-methyl propane, 2-methyl 2-methyl propane. Okay, so this is you see the chain, it is the difference is in chain. So we are having the same, the molecular formula, general formula. This is from this formula we can get the n-butane and 2-methyl propane. So again, हम उससे ज्यादा लॉन्ग चेन लेंगे तो उसका जो वैरायटी और भी आएगा. So basically if we take CH3 CH2 CH2 CH, no, 2, this is CH3. For this, now for this case we can have no the more possible chain isomerism. Okay, तो इसमें हम कितना हो सके. So we'll see, this is 1 2 3 4 5 6. This is called the n hexane. So how I am telling all these names, we learn all these things. So basically this is a, depending on the number of carbon atom, so we can give the name. So basically we'll learn. So if we have a 1, so that will be the meth. If we have a, if we have a 2 carbon atom, so that will be eighth. Okay, so if we have a 3 carbon atom, so basically this is your number of carbon atom, this will be no prof, something like that. So but, okay, so these are the, so it will continue. And if you have a n equal to 6, so that will be your hexane. Okay, so this hexane, this is the normal hexane. So now we can have a substitution like this, CH3 CH2 CH2 CH3. So this is one, and the another is possible is like this. So we can have CH3, CH2, CH3. Okay, so then CH2, CH3. So this is another. So this is now we can see this is where we can have, another, like a CH3, CH3, CH. Uh, mm, so these are the things. So basically these are the different, chain isomerism is possible. We can understand. So basically we are having, we are having C6, C6, H14, H14. So that will give you like three different, chain isomerism. Okay, so this is how, depending on the carbon, so as we increase the number of carbon atoms, so we will have the possible chain isomer, so more chain isomer. So basically this is how we can understand the chain isomerism. Okay, so it will have, so basically here we are having no methyl. This is a branching at, at two position. This is at, at three position. So this is this kind of, variation. This is called the chain isomerism. So basically there is a change in, or the arrangement of, the arrangement of the chain structure is different. Okay, so this is what you can sorry, this is how we can understand the chain isomerism. Then we'll talk about the positional isomerism. तो इसमें क्या होता है, इसमें होता है जो पोजीशन चेंज हो जाता है, उसमें फंक्शनल ग्रुप और डबल बॉन्ड का जो पोजीशन है वो चेंज हो जाता है। क्या है, तो if you take a compound something like this, CH3, CH double bond, CH, uh, CH3, so this is bute to in, this is bute to in. Okay, so this is, this is one, and the other, the the position isomerism. So basically here the डबल बॉन्ड का जो पोजीशन है वो चेंज हो जाने से जो जो आइसोमर मिलता है उसको बोलते हैं चेन आइसोमरिज्म. So basically this will be like this. Okay, so this is bute one in. Okay, so in, that is what, how we are calling in. So when we are having double bond, so that will call the in, and if you have a triple bond there, that will call the ine. So again, so if we have a structure like this, so C triple bond, so triple bond, again CH3, so then bute one, sorry, this is your two, so two position, basically one, again one, two, so three and four. So this is basically two ine, two ine. So ine represents the triple bond, and if we have something like this, HC triple bond, C, CH2, CH3, so that will be bute, sorry, bute, no, one ine. ओके, सो दिस इज नाउ वी कैन सी द, इसमें क्या हो रहा है, जो पोजीशन, जो डबल बॉन्ड का जो पोजीशन है वो चेंज हो रहा है, बिकॉज ऑफ दैट सो वी कॉल द पोजिशनल आइसोमरिज्म. Okay, so again if we take an example something like this, so if you have a alcohol functional group, so like a CH2, CH2, OH, so this is one. So if we change the position of this, the alcohol group, so what will happen, so basically what we can change, तो ये जो बीच में आ जाए तो क्या होगा, you see the position of the functional group here, it is alcohol. If we change, so इसमें क्या होगा, so this will create a positional isomerism, positional positional isomerism. बिकॉज क्या है, इसमें फंक्शनल ग्रुप का जो पोजीशन है, इसमें साइड कार्बन में था, अभी ये बीच का कार्बन में आ गया, तो इसलिए हम इसको बोलते हैं द पोजीशन, द फंक्शनल ग्रुप रिमेन सेम. सो बेसिकली द फंक्शनल ग्रुप इज रिमेन सेम. सो दिस इज द अल्कोहल ग्रुप और द OH functional group. Here also we are having OH functional group, but only difference is the position of OH group has changed. That is why we call the, this is a positional isomerism. Okay, so now we learn about the functional isomerism. So what is functional? So functional isomerism, where we will have the, the basically the functional group will change. So again, the first example if we take, so basically if we take C2H6O, Okay, sorry, CH6O. So from this we can draw a structure like this: CH3 CH2OH. Okay, so this is one compound. Okay, so again this is the possible something like this, so OCH3. Now here what we can see, तो यहाँ पे जो था ये OH functional group था, but for this compound no, we don't have no OH functional group. So basically this is the linkage. This linkage is called the ether linkage, and this is alcohol, this is alcohol, and this is ether. Okay, so this change, so basically functional what इसमें क्या चेंज हो रहा है, फंक्शनल ग्रुप का चेंज हो रहा है, तो इसलिए हम इसको बोलते हैं क्या है, फंक्शनल आइसोमरिज्म. सो अगेन और एक एग्जांपल लेते हैं, जैसे CH3CH2CHO. तो ये जो है ये एल्डिहाइड है, CHO ग्रुप. सो we learn this one is a CHO is functional group is aldehyde, but we can learn same thing like the CH3 C double bond O CH3. Okay, so when we are having this, so basically aldehyde and ketone, so they are functional isomerism. So उसमें क्या है, इसमें aldehyde group था, इसमें ये keto group आ गया. So basically when in the compound, in the organic compound, when we will have C double bond O group, so that we will call the keto or ketone. Okay, ketone. Okay, so this compound is we'll call this is a acetone. So this is, we have to remember the frequently no, in the most competitive exam. So this is what is the common name for this compound. So this is a acetone. Okay, and we learn about the IUPAC nomenclature. Okay, so this is, I hope this is clear to what is no chain isomerism, what is the positional isomerism, what is the functional isomerism. So functional isomerism में क्या होगा, उसमें जो functional एक functional group से मतलब will have the more than one functional group, so that is called the functional isomerism. Okay, so these are the things, these are very important, and frequently this from the chain isomerism and positional isomerism and the functional isomerism, there will be questions and distinguish. So you will be given a compound. From the compound, you have to say what is the possible isomerism, what are the isomerism are possible. So whether it is a only chain isomerism or the functional isomerism or the positional isomerism. So this is the isomerism no part, it is very important for your competitive exam. And the homologous series, what is homologous series actually, in the organic compound, since it is a catenation property, so if we have a compound something like this, so CH3 CH2 OH. Okay, so this is a compound, this is a functional group, we are having OH. Okay, so this is we call, we frequently we know this is a ethanol. And if we increase the each no, this compound is increased by one CH unit, so this is CH2 CH2OH. Okay, so this is, the compound is same, the functional group remains same, and this is, we know the functional group, it decide the physical or chemical properties of the compound, but the only difference is that we are having extra CH2 group. Okay, so when the just we are increasing, we keep the functional group same, we just increase the one CH2 unit, so that is called the homologous series. So basically homologous series for this the alcohol, we can write like this: CH3 CH2 whole N OH. Okay, so n could be 1 2 3 and any whole number, 1 2 3 4, any whole number. Okay, so that is the homologous series. Okay, so again if we take a alkane simple hydrocarbon, so basically CH4, then C2H6, okay, then C2H8, sorry, C3H8, C4H10. Okay, so these are the homologous series. If you see all these, so basically they all increase by one CH unit. Okay, and this is called homologous series. So when you are having the same functional group, and but The only difference with the compound, so basically they are no different with the number of different CH2 unit, so that we call the homologous series. Okay, so so this is one of the most important reasons. So because of that, so we are having many organic compounds. Okay, so now we'll see the physical properties of the homologous series. So since the functional group for this remains same, for so only difference is the melting point. Suppose the melting point and the boiling point, it will no it will change or increase, increase, increase with with their with their molecular weight. Okay, so as we increase the molecular weight, so basically if we increase the number of ch2 unit, so that n, so if we increase the n value, so basically their molecular weight will increase, and their melting point, boiling point will increase. Okay, so that is the most important the physical properties of the homologous series. So apart from that, so basically most of these, the hydrocarbon, if we talk about the hydrocarbon, so basically when we are having c equal to 1 to 3, so basically that is the gas molecule, and when we are having c4 to c9, so those are liquid, and if it is more than 9, so then that will be solid. Okay, these are the general physical properties, and no the the other thing, so it will be all the chemical properties, that will remain same. Okay, so in the hydrocarbon, so now we'll come to the hydrocarbon. So basically this is a compound of carbon and no hydrogen, so basically that will be represent as like a CnH2n. Okay, so in the next class we'll learn about the hydrocarbon and their physical properties, chemical properties, how they behave, okay, and their derivatives. Okay, so we'll learn about that. And till now, so we'll end here, and thank you for your kind attention.